Now, when we're working through the area of triangle problems in question 25, we realise that there's three different techniques we can employ in order to find the area of a triangle. Your formula sheet gives you two. First one, half AB sine C, and the second one, which is called Heron's formula. We only use that when we've got three side lengths A, B, and C. Of course, a variant of that, if sine of theta was 90 degrees, as in a right-angled triangle, we've got half AB. And it's on that basis that we really have our half base times height scenario. If we know the height of a triangle and we know the base, we can, of course, use that ready-made half base times height. So when you're working through 25, we'll treat these as a case-by-case scenario. In question 25a, we've got the height, we've got the base. So area, half base times height, half times 10 times 4, which of course is 20 centimetres squared. In the case of E, we've got that hinge scenario. We've got two side lengths and the associated angle. This is a half times A times B times the sine of C. So half by 5 by 9 times the sine of 65. And on our calculator, we do that in the following way. I always put 0.5 because it's easier. Making sure you're still on degrees. And that will give me an answer of 20.39 centimetres. Centimetres squared, I should say. Now, in the case of I, we've not got any angles, we've not got any heights, so this is where we make use of Heron's Rule. Now, Heron's Rule looks pretty messy. It's the square root of S, and then we've got multiplying S take A, S take B, S take C, where S is the addition of those three sides divided by 2. Now in this problem, 7, 6 and 9, which will give me 11 metres. So working that through, and I'll start with the 7. 11 take 6, which is going to be 5. 11 take 9, which is 2. I better do that on the calculator, I think. So it's the square root of 440. Now, when I tend to do that on my calculator, I just raise that to the 0.5. And that gives me 20.98 metres squared.